Hi and welcome back to Evolution, and this is video number 2, and as promised in the previous video, we're today looking at the evidence for evolution. So there's a lot of evidence around there to suggest that evolution has occurred, and we are going to just touch lightly on a number of those pieces of evolution. You may have in class studied some of these in more detail, some of these you may not have seen. And this is not a thorough examination of those. And when you study biology in year 11, you'll certainly look into some of these in a little bit more detail. So this is just a bit of a glimpse at the types of evidence that there is. So what is the evidence for change? Now, again, as mentioned in the previous video, there has been a number of different explanations for how organisms have changed over time. We've had stories, we've had our religious stories, there might have been legends that might have happened. However, science is an evidence-based subject, and we like to look at facts and evidence that can either support our theories or they might refute our theories. And you'll notice I'm not talking about proof. Science changes over a period of time, and often we'll put forward a theory, which is our thoughts and ideas based on the evidence that we have at the time. And that's not to say that that evidence won't change over time, and then our theories may also change as well. But what we use as scientists is the evidence that we have at hand. So what evidence do we actually have? So the first one, and it's really one of our big ones that we do have to help us with our evidence here, and that is the fossil record. So the fact that we have a collection of fossils over a period of time, from those earliest, most simplest organisms to the more complex and more recent fossils, is a piece of evidence that is really hard to refute. So what scientists have done over a period of time is they've found fossils, so remnants of a life gone by that has been preserved in rock. And they have been able to create a timeline and put those fossils in order of youngest through to the more recent, the oldest through to the more recent, which are our youngest fossils. And they've then been able to divide them into different groupings based on changes that may have happened around that time. So eons, eras, periods, and so forth. And that makes our geological time scale. And really what that is a story of our fossils over a period of time. So let's look at the next little diagram that we have here. And you can see this is not the full geological timescale, it's just a little snapshot. There were some earlier things such as your bacteria and so on. But just to look at this picture, you can see that we have in the far left-hand corner the era. Eons are even bigger periods of time than that, but we've got our eras here. So we've got our Cambrian, we've got our Triassic, which you will have heard of before, and Jurassic, of course, with Jurassic Park. But you can see here that our organisms right down the bottom, first animal traces, our first fishes, our first chordates, our first amphibians. So you can see that we are becoming A, more complex, but B, coming out of those oceans. We've got our reptiles. Our reptiles diversify. We've got a first major extinction, which has killed off a whole heap of our animals that we've had to date. And then we're getting our first mammals, then first birds, then we're getting the extinction of our dinosaurs, our mammals are diversifying, and so forth. And you can see, if you look at the images there, those organisms are certainly becoming more complex. Now, our geological timescale is not complete. It's not complete because not all organisms will go to form fossils. There's a number of conditions that need to happen for an organism to become a fossil, and we will talk about that a little bit more as well. So if you have a look here, one of the main pieces of evidence, and many of you will have probably seen this one in your class, is the the development and the change in the horse over a period of time. So this is over a period of 60 million years, and you can see in the earlier phases, or in the earlier stages, that our horse is about 0.4 meters. That's 40 centimeters tall, quite small. We're looking here at the horse gradually getting taller and taller and taller. Now, size is changing, yes, but if we also have a look, we can see there's some similarities, obviously, in the shape of the animal and so forth, but the size is changing. But the fossil record for the horse is also showing over that period of 60 million years or so that even their foot is changing. So it started off with very simple foot, and you can see the development of that hoof over time, yet you can see those similarities in their structural features. You can see here similar kind of structure in this part of the foot if we look at a cross section of the bone, but that's cutting the bone across the top. But we can see some changes as well, so we can see similarities and we can see differences there. So we need to have evidence to be able to make a claim there. And that study of fossils is actually called paleontology. So paleontologists go out and they are looking for those bones of organisms that they might find, and they are piecing that together over and over to give us our story. So interestingly, one of the oldest fossils, and I'm in the way here and I'll move me, one of the earliest fossils is actually a bacteria that was found, and images of it were found inside some rocks dating back to about 3.8 or so billion years ago. So one of our earliest fossils. Then we're getting simple algae, then we're getting more complex plants, and so on. So how do fossils actually go about forming? So the definition of a fossil is any trace or remains of a living thing from past life. Now, fossils can be a number of different things. It can be a bone, a tooth, a shell, but it can even be an imprint, a footprint, a burrow, and there's different ways that we can use those fossils. So sometimes we might have a cast, or we might have a mold, or it may be that they've actually found the bone itself, but they are still remnants of life past and evidence that life had existed in the past. So how do fossils form? Look, most things, if they were left out in the bush, most things are going to be eaten by our scavengers, or due to oxygen and just our atmosphere around it, they will, with the assistance of decomposers in the soil and so forth, often they will decompose and rot. So for a start, we've got to deal with that. So there's got to be the right conditions for them to form. So often what will happen is perhaps an animal might go to the water hole, it might die, it might fall into the river, somewhere where there's sediment. So often the bottom of our sea or a lake, because they can then be rapidly covered in mud. And mud is a kind of sediment, so we can get mudstone, siltstone, sandstone. All of those are our sediments, and they often are in our rivers and our lakes, and they can settle to the bottom. Sometimes you might get some people, I think we've had evidence recently where scientists have gone and found almost totally mummified people from volcanic eruptions. That depends on the conditions there again, because of course the lava is quite hot and then sometimes can also destroy those organisms. Now, either way, our evidence has to be, or our fossils have to be preserved in our layers of rock, and they are formed in our sedimentary rocks. So if that sedimentary rock is compressed, they become, or the sediments are compressed, they will then become a rock, and that fossil is then preserved in that. So here's just a little diagram that really simplifies what we're talking about here. So we've got an organism in or near water. It perhaps, well, it obviously has died, and it's now covered in sediment. And over time, layers and layers and layers of sediment will be deposited. And how do we get to see them then? Often again, due to erosion, they are worn away and we get to see those bones again when they come to the surface. So it's really important that they are, first of all, they've got to have had the right conditions. They've got to be covered in sediment. They are then compressed and they form our sedimentary rock, and over a period of time they will be exposed. So that's it for our fossil record today. Come back to our next video and we'll talk about some of the other pieces of evidence. See you then.